Hey everybody, this is Dark Guardsman and we're back with another video here. So somebody gave me a really dumb idea for a block to make in Minecraft. And I'm going to make it here on video, but we're also going to use this video as an opportunity to show how you make a mod from start to finish, all the process, everything, including even probably, well, we won't do the build servers because that's what Dmod does. But we'll set up the build scripts, we'll go ahead and set up the base code, set up the folder structure, get it on GitHub, make the block, and we're going to do it in 112, so this will be a pretty modern tutorial, surprisingly. Usually I do 1.7.10 stuff that are somewhat tutorial-like, but we've never done a proper tutorial, and this is definitely not going to be a proper tutorial, as the really goal is to make a block. Now, to start off, let's talk about the block we're actually going to make. I'm going to go ahead and open up Google Docs for this, and we're going to design it. So the very first step when you ever make a mod, don't even start in the code. Just go ahead, open up it doesn't matter what tool you use. I use Google Docs because it protects my files. I don't have to worry about my computer dying and losing everything. It's really good for that. Although I believe Microsoft's Word offers the same properties with their whatever drive they have. I have it disabled on my computer, so I forgot what it's called. So we're going to make a folder somewhere in here. I'm going to just probably open up, I don't think we really even need an actual file for this, so we'll just go ahead and hit new. We're going to make a Google Doc file. Actually, do we even need a Google Doc file for this? No, let's go ahead and do a Google Draw link. So this is the reason also why I like Google Drive is you have all these different things to work with. Google Docs for your normal documents you want to write in and stuff. You can put pictures in those too. Google Sheets if you want to do a whole bunch of data. Google Slides if you're doing a presentation. Google Forms if you want to collect information from other people. So say, for example, you want to ask like several questions. Go like, hey, do you love this mod? Why not? But you can also do Google Draw links. You can do stuff like that. You can make maps with this. You can make a site with this. You can, of course, I've got other stuff in here like Notepad and stuff, but there's plugins. You can actually go get plugins that give you opportunity to do a little bit of everything. I've seen 3D modeling. You can pretty much make a mod from Google Drive with short of actually building. I don't know if they have a plugin for building, but they have editors and everything. It's pretty impressive. Although, on that note, they have the quantity, they don't have the quality. Their software is a little buggy at times. So go ahead and screen this up. So I don't have a name for this mod, but what we're going to make is it's probably going to be a single blocks mod. It is going to be a small machine that's powered off of snow. And you may be laughing right now like, oh, snow-powered machine. There's more to it than this. So there's this concept of what's called a thermocouple or something, I think is what it is. I may be misremembering it, but it's what originally was the idea behind the mechanism thermal generator, the one you kind of can put next to lava and it'll make power. The concept is that you would have two pieces of metal that you would connect with each other. And let's go ahead and just duplicate this real quick. And these pieces of metal will be connected, and there'll be two different materials. So you may have like copper and tin, and depending on the materials, how much power it actually produces. But they'll be connected and they'll be fused right in the middle. And what you do is you stick a heat source on one side and something cold on the other side. And the fact of the differential of heat will generate power. And I don't know exactly 100% how this works because I was told it in college of how it works down to the fundamental level. But it's been such a long time since I've done that because I haven't done engineering related classes since 2013-ish is when I actually switched over to computer science. But in theory, you would have two different metals. So you have like metal A, so metal A, metal B, and these would be connected. And then you would have, if we can get another box here, I've completely forgotten how to use this tool all of a sudden. So we would have a heat source over here. And I think actually this, maybe you put it up here or something. It doesn't matter. I'm just telling you the concept, and we're getting to the design part. So when it comes to conceptually design, you don't actually have to be realistic with things. Or at least I'm going to be using a realistic approach to this because I want to actually put some lore behind this and explain how it works in a really interesting way. So let's go ahead and set the color to this to something else, and we'll go ahead and set the color to this to like red so you understand that there's heat and cold. So you have heat and a cold source, and this will produce power. And what we're doing is the cold source is going to be snow, and the heat source is going to be actually lava. So when we craft the block, we're going to probably use a bucket of lava, a couple of the magma slime, whatever things they are. You know, the thing you take a blaze powder and you make a, I forget the process. We'll get to that eventually. So we'll have those in the recipe, and that will produce our heat. And because we're in Minecraft, we're going to claim magic is maintaining the heat source. So this is going to be a magic-based block, but it's going to produce power. So we're going to have an actual power output on this. And that's not the only thing that's going to be about this. So we're going to have a little cool thing. So in the process, so we're going to have, say, like snow above here. So we'll have snow. And the snow is going to be our cold source. So I'm going to actually just color that white because that's what snow is. and this is going to melt, and it's going to also produce water. So we're going to have a double use for this machine. This machine will A, produce power, B, produce water. And it will, of course, delete the snow. So over time, the snow will decay. So I'll make a config option at a future point on that. Maybe not in this video. I don't know. We could do that. So there's that option. So let's go ahead and put this down here. So we'll have power. Let's just do watts, because I think we can make watts fit in there. Yeah, close enough. And then we'll have water over here. Wow, that really doesn't want to fit in there. So we'll have water. I'll go ahead and color that too. So a really important thing when you're making diagrams, try to color as much as possible. So if you say, just imagine you couldn't actually read the words and you were looking at this and you had to actually utilize this information, having it color coded really does help, because then you can see it, look at it, and figure it out. So we're going to have our snow, and we can also do some cool things like make arrows here. So this will be our snow. And then we're going to have a lava, so we'll make lava. And we could actually make the lava like a consumable item. I am not going to do that, though, because that makes the whole benefit of having this not very useful. So go ahead and do that, and we'll color code that. And that's going to be what this is. And how this is going to work is we'll have heat on one side, this on the other, and this is going to output power and water for us. And that'll be our block. Now, what it will actually look like is what we'll have an actual block here. And it'll be a really simple block. So this will be our machine. I'll go ahead and do that, and we can center it here, just make it a little bit nicer. And we will put this just gray, and then we'll have, and I'll go ahead and just copy this really quick so I can get the same size. We'll have our snow up here. Yeah, we'll go ahead and change this to snow. And this will be above us, and the idea behind this is you would put this in an actual snow biome. So someplace where it would continuously snow, and it would have that, and our machine would go ahead and take and it would consume this. So this will be our consumable. We'll go ahead and put it at the top here. So consumes, and then we'll also make a couple other things. So we'll have an output here. So theoretically, you would also probably have a couple pipes with this. So you would probably have a water pipe, and we'll go ahead and center that too, because you'll probably build a ton of these machines, and you could use Ender IO cables for this too. There's a wide variety of what you actually could use to do this. I'm thinking in terms of BuildCraft pipes right now, because that's just, I'm entirely accustomed to that. And we'll go ahead and duplicate this just to show off that you would, in theory, probably build it like this. You might have, say, a slab above the pipe just so you don't have to worry about it. Although I think snow does actually grow on the top of the pipes. So this would be maybe a slab, and we'll color code that real quick too, just to make our life easier. And you would have your water pipe, and we can go ahead and, say, pull this down. That did not format whatsoever. You have your water pipe going off, and your water pipe would go somewhere. And why you would need water, we'll get to in a second, because this is going to be another mod for another day, what you can use the water for. But the main thing behind this is it'll produce a very small amount of power. And what we'll do is we'll keep the machine cheap enough that that small amount of power actually will be maybe on par with solar. Not quite, because we do want this to be considerably an El Cheapo form of power. Although maybe just enough that you aren't going to build an entire field of these and lag a server out. And I actually wonder if we can use an on-neighbor block update event to actually check if we have snow. And then maybe we just say, okay, maybe around 100 ticks we consume the snow. We want this to be really slow so that way we don't lag a server out. We'll get to the design part of that a little bit. First, we'll get all the concepts up, and let me go ahead and copy a few more pieces here. And we'll go ahead and do this. And then we'll code these yellows. This will be pretty much how you set up. You'll have your power, and you'll have your machines, and they'll produce water, and you just suck it out one side, and you'll have power, and you suck it out the other side. We're going to use forge energy so this will be compatible with a little bit of everything, but there's the design. So we've got that part done, and this is basically, as I said, this will be the first step you do, is design your actual mod. Second step, make sure you have some music on. So we'll get that solved really quick, because I just noticed I have not enabled the music for this, and it will get rather boring just sitting here and watching me do work if you don't have something kind of tunes to play with. So we'll go ahead and flip that on. I didn't select any music, so it's just going to be random, but that should do the trick. So you got some music, really good idea when you're working, have some kind of music to listen to, have some kind of TV show to watch. It's not actually one of the steps, but we'll get to it. Next step, you want to set up your folder structure of some kind. So in this case, this is going to be a 112 mod, so I've already got a folder for 112, and this is going to be an SMB mod, so we'll go ahead and do this. We'll actually start with GitHub on this process first. So we've got our drawing, and this will be SMB, we'll call it snow power. That'll be the simplest way to take care of this. And one thing we did forget to do is draw an arrow that we say we consume this. So that way we know, and remember that it's not exactly important because the mod is so simple in concept, we don't actually need much information. But we're going to need to put this on GitHub. So if you have a GitHub account, you just go to your GitHub, create a new repository. We do have an organization account, so it looks a little different, but the process is basically the same. You can set up your repository, and this will be Snowpower. And this will be using thermal, and we'll call it thermal delta to produce. If I can remember to spell today. My spelling has been really bad lately. Using thermal delta to produce power from snow and lava. And that'll work. Initialize with readme so you can clone down, and then what that'll do is that'll just dump in the name and the actual information, and yeah, it populates down here. Then you'll hit clone, you'll grab the link here, you'll go over to whatever system you actually want to use, and you'll just hit clone on it, put a URL in here, and of course you want to send this to our actual 112 folder. So let's go ahead and pop this up. Good idea to organize by mod version because you're going to have to update your mod at some point in time, and you really do want to make sure you keep records of your older versions in case you have to come back and like emergency bug fix an older version. Even though a lot of mod developers tell you don't support older versions, there is some necessity in supporting older versions. For example, somebody just revealed a packet issue and voltage for me that has been in existence for who knows how long. I now have to go through a couple older versions and fix that, so that way people who are still running older packs can patch their versions. It's up to you though if you want to do that or not. Really not a mandatory thing. So we'll go ahead and clone this here, and it should set the file name correctly, so our file names will be consistent. And we hit clone, and this will download it for us, and it will set up the file for us. So we don't even have to set the file, which is basically you can consider your GitHub step and you were setting up your file directory step at about the same setup, although there is a bit more we have to do. So this will just create our folder. Our folder is empty. We still have to do, for example, create ourselves a source folder so we can keep track of all of our source folders. And this will be like source, I believe main is the next one, and then Java after that. So this is I believe Maven setup, don't quote me on that. There is actually some kind of methodology, the reason why it's source main Java. And of course you also have inside here with the Java, you believe you would have a resources folder, and that's where all your textures go. Let's double check this really quickly, and I always double check too. There's nothing wrong, even if you're like the master of programming, to come back and check things. Everybody does it. Even us who are really experienced have learned that there's no shame in it in double checking your work, and we also have learned that you can't master everything. So yeah, so source, main, yeah, and then of course it'll be the length. If you do Scala, you can call it Scala. Cool thing, actually, if you ever do pick up Scala, you don't actually have to name your folder separate from Java anymore in the newer versions. They fixed that, although Scala is being abandoned after 112, so don't pick it up. Same thing with Coltan, I think is what the other one is that everybody keeps promoting. It's not being abandoned, of course, because it compiles up down, I believe, into Java, so you don't have to worry about that. But Scala did require a library to function. But yeah, so we get in here, and then of course we would come in here and we would just set up our folder structure. So you want to also set your folder structure up in here. So this would be your actual working directory for your stuff. So when it compiles, this is the stuff that would show up in here, and we would do a com and BuiltBroken because that's our organization name. What you guys want to do can be anything. The recommended way is that if you have a website that you distribute your mods on, do your package structure after that website. It's just kind of been the standard that's been used for ages. Basically, since Java's been created, that's been the standard. And you would see with Java, it'll be like org.java or something, or just flat Java, I believe. You can also just flat name it as well. So if you have a mod name, say we could call this Snowpower, which we actually are going to do. We're going to come in here and we're going to just make a package called Snowpower. You could just call it Snowpower dot and then your package structure. And we would make a few packages in here as well. And you don't have to make all your packages in here. I'm just going to do it anyways. So we're going to have a content package. This is the way I like to do it. You don't have to do it this way. The reason I do content is that, say we come in later and we have some helper classes, you would then make a folder called maybe helpers. You would make maybe another folder called data in here, and separating all this stuff from each other really helps you organize what you're doing. So in your content is all your items, all your blocks, all your entities, everything that would be considered an actual object inside of the world. Anything that's not an object in the world probably should be in another package. So for example, if you make a class file that has to do with the position data inside the world, so example would be blog pods that Minecraft has, you would stick that in your data folder because it's just raw data. There's nothing there. There's nothing that ties it to Minecraft. There's nothing there that ties it to anything else. So it's basically just data. But your helpers would be a little bit of different stories. So you would have helpers or utilities. They may be tied to Minecraft, they may not be tied to Minecraft, but they're definitely not content. They're not something the player would hold in their hand or interact with in the world. So you throw them in the helper class, and etc, etc. Anyways, we're probably definitely not going to have a helper or data. We're just going to have content. Probably, to be honest, we don't even need this, but I like to keep my stuff separate and organized because it makes life easier. Next step after you get that set up, and actually we need one more thing to do real quick. We want to make sure we actually create our assets folder. So when you actually do your stuff and you actually make your textures, everything goes in the assets folder, and inside the assets folder is the name of your domain of your mod. So we'll get to that in a second, but I'll go ahead and make the asset folder. That way it shows up inside of IntelliJ here in a second. So we pop all the way back up, go to the resources, and we would toss in an assets folder. And then we would make another folder in here called Snow Power. Now this is important that this is a unique name, because this will conflict with other mods if it is named the same as another mod. Usually you will rarely run into that. If you ever do run into that, easiest way to do it, just put a number at the end of it. It's not that big of a deal. Like if you have Snow Power 3 or Snow Power 4, or if you put like Snow Power your name, it may look weird, but it works. It separates the files out and uniquely identifies it. Because also another thing is that Forge will put your domain name in front of everything. So if you register a block, it will be Snow Power colon then the block name, and which in our case it would just probably be machine. We're just going to call it machine. There's no reason to like make another name or anything like that. So we get this done, and let me just double check to make sure I got all the folders correct. So yeah, source main, name of the language, yep, we're cool. So we got there. Now after you get all the folder structure up, you can set your mod up. Now the way I'm going to do it is not going to be the way you're going to do it. The way you'd probably end up actually setting up your workspace is you'll build the build scripts, and then you'll run setup decomp workspace. There are tutorials already out there for that. You can go find them. They're not too hard. I may make one in a later date that does show how to do it. For me, because I already have a workspace set up and I hate setting these things back up because they take a while to run on my computer because my computer is just sluggish. Even though it is fast, it is sluggish. So what we're going to do is we're actually going to do project structure, and we're going to do plus, new module, hit next, go hunt down the actual mod that we want to work on. And there's tons of mods in here. I can add them all to the workspace if I wanted to, but I do have some of these on a separate workspace. I actually did get in the habit of doing a lot of the SMB ones on their own stuff. So we'll actually grab this and we'll hit finish, which will grab everything for us. We do have to come down in here and we have to mark this is a source folder and this is a resource folder. If you actually had set this up with a build script, this would have done it for you automatically, so you wouldn't have had to do that yourself. Then we have to do dependencies. This is another thing that would have been done for you automatically. And in this case, we just want to attach it to base. Base is all the imports for everything. It's where Minecraft is in my workspace. I've set mine up differently, and a lot of people have got really weird looks looking at my workspace and be like, wait, why are you doing that? It's because I do like to have multiple mods in my workspace and be able to utilize and do a lot of extra stuff. So for example, I have my API for Voltage separated. I have the base, which is all of the Minecraft stuff, so everything you get with Minecraft and Forge, all in its own little thing. And then I have that linked inside of the engine, which then exports it out to ICBM Classic, so I can work on that. Then I also have this. If you are working with multiple mods, what you do in order to make it work is you build an empty workspace and you just tie everything in as a dependency, and then you set that as your run environment. Anyways, we'll go back to SMB Snow Power and hit apply just to get everything saved, and that should now compile and work everything. We just need to make sure we add it to RZ Minecraft here. That way it will actually load up when we launch Minecraft. So hit apply as well, and then there we go. Snow Power shows up. There's nothing there, of course. So we do want to make another class file here, and I did forget to do this. So one thing with IntelliJ is a little finicky on this, and you can actually get around this by switching to a project view and then dumping down into here. And of course, this will make sure that you can actually see the files. And if you also like project file view, that also works as well. It makes it a little bit more messy though to get through. So we're going to actually switch back to package view, and we're going to go over here to fix that real quick. So if you stack a whole bunch of packages, it'll try to collapse them down. And we just want to put, like, say, a placeholder here, and not even name it, and that'll fix our structure here. So that way I can make the actual mod class. To make the actual mod class, just go new Java class, and you just want to literally call it whatever. You can name it after the name of the mod. I have at times literally just called it mod class. So we're going to call this Snow Power, and that's going to be our actual mod class. And what we want to do in here is just do public static final. Let's say put the domain. This would be string domain, and this will be, we're just going to call it Snow Power. Then we can do the prefix. We're not really going to need the prefix, to be honest. I'll probably use it, but we could have got away without it. So prefix is literally just your domain plus colon, because that's how that works. And then we're going to do the mod annotation up here. So in order to get Forge to recognize that you have a mod, you need to use the mod annotation. And this needs a bit of data. So this is going to expect to see a mod ID. That's your domain, is what that actually is. You can call it an ID, you can call it domain. I'm calling it a domain because that's the legacy name for it. I think that people still actually call it that. So you would do mod ID here, and this would be Snow Power. And you have to use the static reference here for this in order to get it to work, because just that's how annotations function. They expect to see a static final version. You can't have it just a static because it's not finalized, and this one's a finalized data. Because how it actually works is when it compiles down, it'll copy this value to this up here in the compiler and put it in there, and it will copy this value pretty much everywhere. So even though this would exist in the code for reference by other mods, it will probably compile down in order to actually get rid of that, so that's not actually there. Let's close a few of these. Let's actually close all of this and reopen mod. This actually, mod ID is about the only thing you actually need in here. It'll default the name to empty. It'll default the version empty. You, of course, want to make sure you fill these in. So we're not actually going to do anything fancy for this one. If we actually go look at ICBM Classic for a comparison, it does a little bit more detailed information and stuff. It will actually, well, this one also lazies out us too. It just puts it in there. It's actually not a bad way to do it. So you can just do like this, snow power. And of course you want to make sure we do SBM snow power. That way you know it's part of the single blocks mod series. And then we want a version number. In this case, I'm literally just going to copy this entire piece because I don't feel like typing this all the time. And it doesn't change. And our build scripts expect this. So if we actually do want to use the build scripts that I've already built up for everything else, we're going to want to have this here. And how the build script works is that there's a piece of section of code that just goes through and scans all the files and goes, okay, if I see this little tag here, I'm going to replace it with the major version number. And we'll go ahead and we'll do version here, and that's everything we need. Like, there's more stuff in here, like you can put the dependencies in here. We don't have a dependency, so we don't need that. You can do a lot of extra stuff as well. We are going to probably do a proxy system, and we are going to need an instance system. So we'll go ahead and set those up. So public static, and we can't make this final. This actually just has to be snow power, and this would be instance. When you call it, just call it instance, because if you call snowpower.snowpower, it would just be stupid. So you just go snowpower.instance. And of course you would fix this with the actual annotation here. So there's actually an annotation here, mod.instance. You can find it in the same exact package. It's all the way down at the bottom here. In order to, by the way, to get to that, when you see me switch these class files, Control B and IntelliJ will take you there. And there's a few other things like custom properties, event handlers, and we'll do the event handlers in a second. But there's an instance. Of course, there's metadata too. We're not going to do metadata because I honestly have forgotten how it works. It's been that long since I've actually messed with it. So we'll do that, and this just takes your domain. And you're done. So that will load your instance. So when your mod actually loads and Forge actually creates it, it'll load an instance of your mod in here, so you have access to it. And you can gain access, I believe, to other people's mods by using the instance system. I haven't done it before, but it should work. And the other thing we need is we need a proxy. So we're going to have to actually create the proxies ourselves, and we can delete our extra folder here. So we're going to make just two proxies. We're going to make a common proxy, and this is literally just going to be an empty class file because we don't actually have a use for a lot of the information that we're going to need. And then we're going to need a client proxy. The reason for the proxy system is it separates out your code. So say, for example, I have client-only code that I need to run. I can then say, okay, in the proxy, I want this code to run. And then in the common proxy, which will get loaded server-side, we don't have to do that. The reason for this is why this is called common proxy, is this is technically meant to be your code that runs on both sides, and you usually are supposed to have a separate server proxy. Server proxies, by the way, only load on the dedicated server. They do not just load server-side. So when you actually load up Minecraft client-side with your mod, your client proxy is what is loaded, because it loads all the textures, all the models. So even if you're running a LAN server, the client proxy is what's got loaded. And then when you run a dedicated server, server proxy gets loaded. So this is the only one that's going to get loaded, and we extend our common proxy. And that is not what I wanted to do. Tab complete can be a bit of a problem when you're trying to do stuff. So use tab complete with care. So we got our common proxy and everything, and then we're going to go ahead and I'm just going to copy this because it's just so much easier to just copy and paste code sometimes. Now, copying and pasting is generally a bad idea to get in the habit of doing, but you'll find almost every developer does use copy and paste. Anyways, here, so with the common proxy and everything, so you have a client side, so client side, you need to pick a file. This is literally just going to be the class location for it. So in our case, it would be com.builtbroken.snowpower, and then it'll be client proxy. So that tells Forge where to look for our actual client proxy, and then we'll basically have the same piece over here for our server proxy, except we'll change the client proxy to common proxy. And if we had a server proxy, this would actually be called server proxy. That'll work, so that'll actually tell us where to find each one, and when Forge actually does load and everything, it'll create those instances for us, and it will load it into there for us. Okay, so now on to the next step. Next step, we just basically want to set up some pre-init, some registries, and a few other things. I don't think we're actually going to need the pre-init. what we actually are going to need though, and we'll scroll down here, we're going to need the register item event. So this gets called when we need to register items, and we do the block registration event. Block registration is actually called for item registration. So in this one, instead of like ICBM is a mess right now. I got to go through and clean up everything in here. But register block is called first, then register item, then our model should get loaded at some point after that. So we'll have a registered model event. This is the reason why we're going to need the proxies. We can only load the models client side. Although in our case, I don't think we're actually going to have anything fancy. We're just literally going to have a simple call that goes, hey, I need you to load this for me. And we'll go ahead and do this over here, copy this, and we're going to have to put that in our client proxy. And what you do is you just go add override, and when all the calls get called, so when we load the proxy up and it goes to do the call, client proxy is what's going to get loaded into the actual variable. And if we close this and go back to here, so it gets loaded in this variable, and this call will make it up to here. So instead of it calling to client proxy, calling to common proxy, it's going to call it a client proxy. It's going to use this method because we've actually add overrided. By the way, add overrides are optional. They are recommended to be used because it helps you as a developer not forget anything. But when it comes down to the code actually being compiled, they are gone. They're not in the code when they're compiled up. You can actually tell this as it'll actually say retention policy source. If you ever see that on an annotation, that means it only stays in the source code after compile it's gone. There are actually several retention policies, class level and runtime as well. So there will be annotations that only exist at runtime, there's annotations that only exist at the class level, and so on and so on. Okay, so we got all this set up, so we've got our basics set up. Now we need to create our block. So we'll go ahead and make a block, and we're going to make a tile entity for this too, so we'll call this block snow machine. Actually, snow generator. Try to keep some consistency. We're going to stick block container. This is going to require us to override the constructor, and of course a create tile entity. I always lose track of everything. And for our material, we're going to do material.stone. And the reason why we're going to do stone is just because we want this to have a more of a rocky appearance, because it's going to be kind of like a vanilla furnace is what I'm thinking in my head right now, that has just a few items inside of it that make it function. More magic based, as I said in the beginning of the design. So we go ahead and we have the rock in here. We do also want to do a few other extra things. So we want to set a localized name. And this is where we would actually use that prefix. So snow power.prefix plus, and then the name of our machine, which in this case is just going to be snow generator actually. This is expected to be lowercase and in newer versions, so when we hit 113, I believe lowercase is enforced for unlocalized names. And the current version of 112, you are not required to do it, but it is recommended because it supposedly makes life easier. The reality is it doesn't. And actually, for the unlocalized name, in case we actually want to add a few other generators to this, I'm going to call this generator.snow. And this just kind of helps. You think of a reverse package system, because if you look at how the package is done up here, it goes com, BuiltBroken, snow power, content. If you read this in reverse, this is the content package for snow power for the BuiltBroken.com site. A little confusing, but so when you do that with localized name, it helps to do that as well. And it also helps kind of organize everything, so when you're scrolling down, you can find like, oh, here's all the generators. Here's a snow generator, here's a snowball generator, here's a gravity generator, whatever. We might only have a snowball generator, that's another thing I might put in here. And for it being a single block mod, you may be going like, wait, why you have multiple blocks in single blocks? Well, technically the same block, but you'll have a different tier version. The other thing you want to do with this, other than localized, is you want to set the registry name. This is actually mandatory. You can get away without the unlocalized name and it'll just look weird, but the registry name, if you do not provide this, it will crash. Because it is expected. This is actually the name of the block when it actually shows up in game. In this case, I don't know, we could actually do generator.snow as well. I don't think there's any rules against how you actually put it in here. There are a few characters of course you cannot have in here, like colons are not recommended. You don't want to have an extra one in there, it'll break things. So in this case, we're just going to do snow generator, and we'll just do it that way, so that way that would be what our block shows up as. You also want to do things like set hardness, and we'll go ahead and set this to 1, and we'll set resistance. I believe actually does this set? Yeah, this sets resistance for us. You don't actually have to do that. So you just set the hardness. The reason why you set the hardness is it starts off at 0, so your block will instantly break when you touch it. And the material already defines what tool is used, so it'll tell us it's a pickaxe. You can override that if you really want to, but that's not what this video is about. The other thing we're going to need is we're going to need our tile entity. So we need a tile. Yeah, we'll do tile entity just to keep consistent. Usually you'll see a lot of developers just call it tile because it's easier, you don't have to type as many things in. Whatever you do pick, keep consistent with it throughout your entire mod. If you do suffixes, prefixes, whatever, be consistent. Though I do recommend don't do what I've seen a few mods do and prefix your mod name in front of all your classes. You don't need to do that, and it just makes reading your code incredibly painful. And we extend tile entity, and we're going to need to implement I believe it is tickable. Yes. This will allow our block to actually update. We are going to need to update. And we'll get to that. And in here, we're going to want to make sure we actually do tile entity snow generator, so that will actually, when our block is placed, it'll actually do that for us. We aren't going to need any rotation right now, so we aren't going to do anything special. So this is basically the end of this class file. That's how simple it is to do a tile entity. You don't have anything special going on. At least I think so. Actually, when I say that, there's actually one method we do have to override. Good thing I remember this, so we would have loaded up and it would have broken. For some reason, block container returns invisible, and I think this is because of how tethers are used. But you want to override this method, and because we're going to actually make a texture on this, we want to use, I believe, either model or entity animated. It'll actually tell us if we go and find the super method of this. So if we go super.get render type, it should tell us. Yeah, okay, so model for mixed tether and static model, model animated for tether only, liquid for liquid, and visible to skip all rendering. So we don't actually want to skip all rendering, so we're going to want to return model because we want effectively just a very simple model. And this will give us tether support as well, so if we want to put tethers on here later, we could. I don't see a reason for tether support unless we want to maybe do some special animation, like maybe have like some moving parts in the front, which we really don't need, and that of course will cause FPS lag if we did. So we got everything here. Now for the actual code, we'll get into that in a second. First, we want to make sure we register everything. So we're going to have to pop back into here and register our block. We're going to store a block in here. Now, some people say, okay, you need to use like a object holder annotation. You could use that. I'm not going to use that. I'm old school. And I'm just going to call this block snow generator. And I'm just going to assign it. So this will be public static. You want to make sure it's static so people don't have to call your instance variable every single time. Plus, this is going to be your thing. You also want to make sure you document things. You would say like, hey, this is the block instance for the snow generator. It's optional, and you may think it's unnecessary because you can read the field variable, but it does help because if we go to another class file and we hover over the field for this, it will actually tell us what it is above it. When it comes to registry, you just want to go event.getRegistry.register, and you do block snow generator equals new block snow generator. And because we already set all of our variable data inside this, and we did forget to set this as public, we've already set all of our localized name and registry name and everything. We don't have to do anything with this. We just have to register this. Although we do have to come down here and go event.getRegistry.register new item block. And we're going to have to pass in block snow generator, and then we also have to set the registry name on this one. And we're going to do block snow generator.getRegistry name for that, and we're done. That registers our item block so we can see it in our inventory. And this will register the actual block so it exists inside the game. And then we'll get to the model things. The model down here, I'm actually going to just copy some code from ICDM here, and I'll explain how it works. So for this, we just want to, we're going to pop down a code piece. So we're going to do this real quick. We just have to call model set custom resource location. I have a feeling this is not mandatory to use, but I haven't got the mod to work without it. So we'll pop this in here, and we'll just register it this way. And this one, we're just going to do snow power dot block snow generator. This will register. It'll convert our block to an item. We could have actually set up an instance for the item as well, and we could have grabbed that if we wanted to. This is, in my opinion, is easier. Our metadata is going to be 0. We're not going to have subtypes, so we don't have to worry about that. And we're not going to have a subvariant of this, and our variant is going to be inventory because we are just, what this is literally used for is to just set up our inventory render. We will have a separate model for the actual block as well. So, but the block one does auto load from what I've seen. Item one for some reason doesn't. I don't understand if I'm just setting it up wrong or whatever's going wrong, but we'll assume it doesn't work easily, and we're just going to do it this way because it's quicker to sometimes do it the wrong way than to sit there and just spend all day trying to figure out the right way. Now, don't get me wrong. If you could figure out the right way, do it the right way. But yeah. So that should register our model, should register our item, and should register our block. So we have everything going. We do need to set a creative tab for the block. I did forget about that. So what we're going to do is we're just going to put this on... I need to think of a tab because I don't want to make a tab for this mod, even though we could. So let's go really quickly and put this on a tab. It's not going to be a building block. It's not a decoration. It's not a brewing machine block. So where do you put something like this? We could just put it on the Miscake tab. And I think it's like maybe the best bet right now. Yeah, they've changed the tab since I've last looked at them. But yeah, Mystic will probably work. That'll just give us, it'll be there so we can find it. And that'll work everything for that. So we should be able to load into the game and watch the game right now. And we should be able to find this block. Now, we don't have a localization yet, so the translation's not going to be there. We don't have a model, so it's going to not render whatsoever. We'll get to that in a second. Probably actually get that in the next video here. So we'll go ahead and make sure this runs, and then I'll pause and then set up another video here. That way these are broken into sections to more easily browse them through them. And we just wait for Minecraft to load. And you can ignore the JSON window, that's something custom. Interestingly, the software is actually capturing the NVIDIA frame rate render. 100 frames per second while loading. And then I look at every other window on my screen, and the system we're using for music is doing 15 and OBS is doing 30. Although I believe OBS is actually locked down to 30, and I could up it to 60, although there's no reason to do that. That's a load up through. Biggest part about like the actual load time here is just waiting for all the models to bake. And there we go, we're loaded up. Pop into here. It's actually a world I've already been using for testing ICBM, so you'll just ignore everything and we'll get there eventually. As I was going through and testing recipes here. So what we're doing is we put this on the Mist tab, and what we should see is somewhere in here there should have been a block. And I'm not seeing it. So next best thing is we're going to type in the word snow and we're going to look for this, and I don't see it either. You know what we forgot to do? There is a really important thing that you have to do in order to get things to work properly, and I completely forgot it, and I forget this on every mod I work on. So in order to get the annotations to run, there actually is this event subscribe bus thing here, and what this does is this tells Forge that you have statically registered events that you want to run, and these are statically run. If you didn't want to do statically run, you could actually do Minecraft forge.eventbus.register, although that's a little bit more complex in process. This is easier, and you can actually define what mod you want this to run in. So the mod ID to specify for loading here. So this is actually a really cool way to do mod proxies. So if you say you wanted to support like open computers or something, you could set up an event bus that ran only when open computers was in existence, and then you could provide your block registering methods, your item registering methods, and your model registering methods, and it would work. It actually is a really cool idea. So let's load this one more time just to get this to run. It's taken us almost 40 minutes just to get everything set up. Although I do admit most of that was talking. Under like a normal process, you probably could get this taken care of in probably 5 minutes, get everything set up and running. Maybe 10 minutes if you're new to this. Although it depends on each person. Like you probably could have cut out this entire process here and just put like an version tag up here. And of course, you could have cut this out as well. And that would have made it a little bit quicker. You of course do have to do all this. Once again, we can ignore the JSON thing and wait for it to load. I think if I probably turn the recording software off, I think I can get this to go to 200. Although it still blows my mind that it's that high when you're inside of a GUI loading screen. You probably could have dropped that down to maybe like 15, maybe even lower, and the human eye would have not noticed the difference in frame refresh from the GUI. It's a really important thing, like if you ever get into game development. Yeah, you know it says this is locking down to 30 now. That's a more consistent number with how often you really should update GUIs. And then once you get down into loading, 5, 2, 6, 16, and we're up to 60. And then mine, of course, will lock somewhere around 60 because I do have refresh rate on it. Let's actually experiment with that really quick since I don't think any of you really care. Video settings. Oh, we do a max refresh at 120, yet it's locked at 60. I think it's because, oh yeah, it's VSync. Hold on. Video settings. VSync off. 121. Unlimited. 200, 360, 410, 400. I really don't need that kind of refresh rate in Minecraft. I really don't. Actually, I think it causes more lag than it does help with. Anyways, let's go find our block, and less me being amazed by my frame rate. And there's our block. So this will show up as a 2D item in your inventory because it can't find the inventory order, so it doesn't understand it's a block. And then when we actually go to place it, it will show up as a block. And what it'll do is it'll tell you right on the side that it goes, hey, I can't find this because I'm looking for normal variant I haven't found in my registry. You can actually change what variant you're looking for. You could say, okay, my block state would be, say, rotated north or so-and-so. And this will say, okay, I couldn't find rotated north. And do various other things. But we'll get to this fixing the textures in the next episode, and then the episode after that we'll do the logic for the actual tile. Usually when you would be programming this as an actual mod, you would do the logic first and the rendering last, just because doing a proof of concept that you can actually get the logic working is more important than rendering. If you waste a lot of time on rendering, you may get something that looks pretty, but if it doesn't work, then, well, time has been wasted. But we're going to do it in the reverse order because it should make the videos shorter, because I think the tile logic video will be longer.